Good morning, everyone. What a wonderful audience. So, if you're not working for OCSIAL or JEC, then thank you so much for coming here. You must be really interested in graphene nanotubes. I'll try to make the best of these 20-25 minutes, and at the end of this time, let's have a question and answer session if you are still awake. First, by the name, OCSIAL is oxygen, carbon, silicon, and aluminium. These are four of the most used elements by mankind. We are a Luxembourg headquartered multinational company. We produce, as what is written on the slide, graphene nanotubes. Our brand name for graphene nanotubes is Tubal. But what is a graphene nanotube? I'm pretty sure most of you already know graphene, which is one atom thick sheet of carbon. If it is rolled into a seamless tube, it's called a single-walled carbon nanotube or a graphene nanotube. In case of Tubal, our single-walled carbon nanotubes, the diameter of this tube is about 1.4 nanometer. The length is 5 micron and higher. The thick sheetness of the carbon atom is just one atom. So you can understand it's very, very thin and very, very long. This special structure of carbon to carbon bonding results in some exceptional properties for these carbon nanotubes. For example, in tensile direction, they are 100 times stronger than steel. They are almost as conductive as copper, but 20 times lighter than copper. The aspect ratio is 5,000 to 7,000, and sometimes it can go to 10,000 also. So if you take all these properties, you get an additive which you can put in a very, very small quantity, almost in parts per million sometimes, and get these properties inside the polymer matrix. Primarily, graphene nanotubes are used to provide electrical conductivity and improve the mechanical performance of any polymer they go in. Another interesting fact about graphene nanotubes, they are pretty stable chemically, so you can use them in a lot of polymers. Almost 75% of the polymers known to man can benefit from graphene nanotubes. You just mix them in. Now, being of a nanoscale, they are notoriously difficult to mix in the powder form, as some of you must have observed yourself also. So most of OCSIAL's effort in product development goes towards making these graphene nanotubes easy to mix and to be mixed with the standard production equipment. We do not provide, unless it is specially requested, pristine nanotubes. What we provide is graphene nanotube concentrates, either in a suspended form in water or any other solvent, which is the dispersion, or in the form of a flaky paste, which is graphene nanotubes suspended into a neutral carrier for your use. I'll dwell more into that. The prime value proposition which graphene nanotube bring in polymers, composites or pristine polymers is it increases the product value by making your product last more. It increases the business value so that with the same products, with the same composite or with the same material that you are producing, you can now use it in more segments. If you are making something for marine environment, you can also use the same in oil and gas environment because the properties are enhanced to that extent. And one of the most important thing is environmental impact. Sustainability is at the core of OCSIAL's innovation. So we believe in doing better with less, one of our key mantras. Nanotubes, as I just mentioned, are used in ultra low dosages. That means you use very less material. They increase the mechanical performance. That means whatever you have produced can last more, can have more service life, thereby impacting the environment less. Coming to the specific point of electrical conductivity, it is one of the most sought after and in commercial use of graphene nanotube. Well dispersed tubal inside a polymer creates its own 3D conductive network which can give electrical conductivity because now the electrons can transfer through the whole polymer matrix. Just a fancy video to show the same. So this was just a fancy way to show how graphene nanotube behave inside any polymer matrix. Yeah. In comparison to some of the other additives which bring electrical conductivity like conductive carbon or liquid anti-static agents, graphene nanotube bring a whole gamut of benefits. For example, you can get a full range of resistivity, you can get clean production facility, you get permanent conductivity, and you can have an option of a lot of colors. I'm just curious by the show of hand if anyone can tell who is a fan of processing conductive carbon here. So anybody who loves processing conductive carbon in their facility either is working for conductive carbon or hates their facility. That's what we believe, because it makes everything black and it's really, really dirty. Also, there is a very limited influence on viscosity of the polymer by using graphene nanotube in the required dosage. Well, they have a very high aspect ratio, so they do bring some thixotropy. But if you use nanotubes in the requested range, in the desired range, the viscosity influence is almost minimal, as you can see in this graph. You can have conductivity, permanent, and color also with graphene nanotube. That is something very, very unique. Most of you who have used anti-static or conductive material right now, for example, anti-static grates or anti-static gel coats or anti-static SMCs, would be used to getting black color. But with nanotubes, it is possible to have conductivity as well as some colors also. Now, let me move to some more commercial cases. The success of nanotubes in commercial area is this slide primarily talks about filament winding composite. For example, in tanks and filament wound pipes, you would find addition of a very small amount of nanotube. This is 0.5% of nanotube, which is 0.05%. It's extremely low of real nanotubes. You can get conductivity. You can get colors, that means colored pipes and colored tanks. At the same time, you can get the whole range of resistivity with mechanical performance, either enhanced or retained. Same with pultruded composite. One special point about pultruded composite is it is by value extremely, let us say, cheap. So adding nanotubes to pultruded composite doesn't increase the price of pultruded composite to an extent that it becomes impossible to buy. This is one of the great myths that we have been busting, that nanotube addition makes the product or the polymer very expensive. It doesn't show. So you can see this polymer, for example, in the cable trays or in the gratings, you add extremely low amount of nanotubes, sometimes 0.02% of nanotubes, and get whole range of conductivities. These pultruded parts can now be used in ATEX environment, that is the environment which has explosive in the atmosphere, and these can be used in other parts as well. For SMC composites, these are junction boxes or any other housing assemblies which are installed in, let us say, any oil and gas environment, or let us say a scrubber which scrubs the dust out of the air. These need to be anti-static, otherwise there would be a huge sticking of dust particles to the SMC composite. You can make SMC composites colorful as well as permanently conductive with tubol. For spray application like gel coats, carbon nanotube bring a very unique benefit, particularly in the case of tooling gel coat, where addition of tubol to tooling gel coats can have a very positive impact on the productivity of your molds. It's very easy to open molds without any static charge. Also, it is safe. And frankly, no one is a fan of getting shocks by static charges. Similar is the case with any other coating application and also the gel coating application. If you see the kid there with the hair straight, it's static charge. Now, touching on the topic of mechanical reinforcement, nanotubes can be introduced in the polymer matrix by two methods. One, by inculcating nanotubes directly into the resin polymer, making the polymer inherently conductive, or putting the nanotubes somehow on the surface of the fiber, thereby increasing fiber resin interface. With both the methods of inculcation of nanotubes, we believe these two properties, these two methods happen, and because of that, the strength of the polymer is increased. One, the neat composite cracks have now longer path to tread. So micro crack propagation decreases significantly because the nanotube has now reinforced the polymer matrix. Second, there needs to be a fiber or nanotube pull out with every crack. So more energy of the crack is dissipated in doing this. These are two hypotheses we have for how nanotubes reinforce the polymer composites. Some of the cases for nanotubes inside cylinders. For example, you can see this on our booth. This is a safer cylinder which is used by firemen. This is in its class one of the lightest cylinder. This has been possible by using nanotubes inside the polymer matrix. An interesting case is for these bikes where the impact strength of the frame is increased. This is a carbon fiber epoxy composite. Now, one of the interesting and immediate benefits of using nanotube inside a polymer matrix is increase in fracture toughness. If the application is such that it needs high fracture toughness, this graph shows that nanotubes can really enhance it at very, very low addition. So that is an excellent value proposition, especially for something which gets a lot of impact, like the bicycle frame case I just shared with you. This is a same image of a neat composite and composite with tube ball inside it. As you can see, nanotubes have formed their own reinforcing bridges between the fibers and between the fiber and the resin, thereby reinforcing the resin. Now a little bit about the company OCSIAL. We were incorporated in Luxembourg in 2010. Right now, we have more than 1,500 clients and partners. We are a commercial company, we don't do much of the lab work outside. We produce 97% of global graphene nanotube production. That means we work a lot on the IPs, so we have more than 80 plus patents and in this application. We love to collaborate with fellow technicians, fellow industrial labs. So please feel free to contact us for any collaboration. We have 3 reactors, Graphitron 1, Graphitron 50, and a new plant which is proposed in Luxembourg. We have 3 R&D facilities or product development facilities right now, one of them in Shanghai, another one in Luxembourg. And in brief, we have a global footprint, once again headquartered in Luxembourg, where most of our key technical team sits. Something really, really important about health, safety, and environment. OCSIAL is a very conscious company when it comes to health, safety, and environment. We are the first REACH certified nanotube company in Europe. We have also the EPA consent. If you have any questions for me right now, I'll take them. It's time to wake up. I'll just stand here till you till you come up with few questions, and it's okay. I'm free. Yeah. All right. So you can come to our booth for any questions in all the languages that you want to speak in, and we'll be glad to answer that. We are in Hall 5G12. Thank you so much again.